So there's actually two solutions for this problem, and we're first going to go over the solution that's easier to solve but harder to see. So so figures the zeroth figure, the first figure, and the second figure. The zeroth figure has one non-overlapping unit squares. The first figure has 5 non-overlapping unit squares. The second figure has 13 non-overlapping unit squares. So we can we can set the first figure as 0 squared to plus 1 squared. And obviously 0 squared is 0 plus 1 squared, which is 1. So that is the number of non-overlapping squares. And this is a you'll see later why this makes sense. So the second one we can set as 1 squared plus 2 squared, and that equals 5. So and then we can set that as the third one too, as 2 squared plus 3 squared, which is 13 as well. So, do you see a pattern here? If you didn't, then I want you to try to think harder. Okay, now we're going to show you the pattern. So, the pattern is it's n, which is the figure number, and in the first case it's 0. Figure number n squared plus n plus 1 squared. So that's the formula for finding the number of non-overlapping unit squares by just knowing the figure number. So right here, the first figure is the first figure, and if you plug it into the sequence, it's 1 squared plus 2 squared. And we see that it works because we have already tested that. So we can test it also for the third term if you want, and just for extra just to make sure that this formula works. So if the figure number is 3, then we know that 3 squared is just 9, and 3 plus 1 is 4, and if 4 is squared, then it would be 16. So 9 plus 16 is just 25. And what does the problem tell us that the number of overlapping squares are? 25. So we know that this formula works. So how do we specifically find figure 100? Well, that's easy. We just plug 100 in because that is the figure number. So it's 100 squared plus 100 squared plus 101 squared. And what is that? That comes out to 20,201. And is that an answer choice? Yes. So, C is the number of non-overlapping unit squares, that there would be in figure 100. So, if you didn't see that off the bat, then I'm pretty sure you saw a different approach. And this is using arithmetic sequence. So, the 0th figure is 1, containing the number of squares, and the first figure is 5, the second figure is 13, and and the third figure is 25. So, what do we see here? So the 0th term and the first term. So we're just adding 4 between the 0th term and the first term, and we're adding 12. We're adding 8 between the first term and the second term, and we're adding 12 between the second term and the third term. What do you see here? Well, I see an arithmetic sequence because we're adding the same number, the same difference between each add. So we call these gaps, right? The number, how much we add, and how many gaps are between the figure 100? There's 100. So we have 4 uh 4 4 plus 8 plus 12 all the way to what 100 might be. And we can simplify this by doing 4 times 1 plus 2 plus 3 all the way to 100. And what is this? What does this equal out to? It equals out to 20200. So that is how much we add to the base number. And what is the base number? It is 1. So we're adding all the differences on and on and on all the way to the figure 100. And the base number, so it would be 1 plus 20,200. And that again equals C. That's your answer.